Today we are working with polygons and quadrilaterals. What is a polygon? Well, a polygon is just a figure that is made up of straight line segments that are closed. So when we take a look at polygons, we have all different types of polygons. A three-sided polygon would be a triangle. A four-sided polygon is a quadrilateral. A five-sided polygon is a pentagon. A six-sided is a hexagon. What most people don't know is the seven-sided, which is a heptagon. An eight-sided is an octagon, nine-sided is a nonagon, and we can go on and on. Every single polygon, each side changes the name of the polygon. Now, most people don't really know beyond eight-sided polygons. And so if we go beyond eight-sided and we don't know the name, oftentimes we'll just count the side lengths that it has, and we would say something like 16-agon, and that's good enough for mathematical terms. Now, these closed figures, the polygons that we look at, we can have regular polygons or we can have irregular polygons. Mostly in math, we want to work with regular polygons. And so a regular polygon simply means that the side lengths that make it up are all the same length and the angle measurements that make it up are all the same angle. So we also can have convex polygons and concave polygons. Now this concave polygon is an irregular polygon because we can see that the lengths of the sides are not the same. And I always remember the cave because it actually makes it look like there's a cave that's going into it. Versus this convex polygon, that would be an example of our regular polygon because we can see that all of our side lengths are the same length, and we can see then that also all of our angle measurements are the same angle measurements. Now quadrilaterals are just a special type of polygon, and we know that those are our four-sided figures. When we take a look at the quadrilaterals, we have a lot of different figures that are considered quadrilaterals. So rectangles, the way that we look at this is we can see that it's a four-sided figure that's closed. But if we look at the rectangle, we know we have two sets of parallel lines, and we can see that I have these tick marks here. The tick marks represent the side length. So where I have a one tick mark and a one tick mark, that means that's a single side length. That's the same side length. If I have a two tick mark and a two tick mark, that means those two are the same side length. So when I look here, this side length and this side length are different, and I don't need to identify what the measure is. I can just look at it with the tick mark. Now the parallelogram looks almost exactly like the rectangle. The only difference is this is symmetrical and this is not symmetrical for that. But their other characteristics are just the same. The square just simply means that all four sides are equal measure, but it has two sets of parallel sides as well. Most people don't know the delta. The delta is kind of a cool symbol. We can see that no parallel sides, and we can see that these two sides are the same length and these two inner sides are the same length as well. The kite we're all familiar with, but technically there's no parallel lines in a kite, and the top two line segments are one measure, the bottom two line segments are a different measure, but they're the same going across. The rhombus looks almost identical to the square, and it is very much the same relationship as the rectangle and the parallelogram, in that all four sides have to be the same measure, but the square is symmetrical and the rhombus is not symmetrical. And symmetrical means that you can fold one part over on the other side and it exactly fits on top of itself. This could never fit on top of itself. This would never fit on top of itself. That's what we're meaning by symmetrical. Now, the trapezoid has one set of parallel lines, and we can see our set of parallel lines there. The other set is not parallel, and there's a couple different ways that we can draw a trapezoid for that. And then most people don't know the trapezium, and the trapezium is a four-sided figure, but it doesn't necessarily have any of the side lengths that are the same measure for that. Now, all quadrilaterals or four-sided figures equal 360 degrees when we add the four angles together. And one way we can remember that is because every quadrilateral can be split into two even size triangles, and we know that the degree measure of each triangle is 180 degrees. So I can always solve for an unknown angle as long as I'm given the other three angles. So if I take a look at this quadrilateral, on one side of my equation, I'm going to put all my angle measurements. On the other side, I'm going to put my 360 degrees. Well, when I go and pull this together, I can see that I can gather my like terms of the angles that I know. So 68 plus 126 plus 106 degrees is 300 degrees. Now I have just a simple equation. And so I'm going to subtract 300 from both sides, and I can see that my missing angle measurement is 60 degrees. So this lesson is all about working with polygons, but mostly about that special set of polygons called quadrilaterals. Good luck. I know that you'll do well today.